Okay, in this video, we're going to talk about some basic terminology with circles. So we're going to get into arcs and angles associated with circles. This is going to, I've got a note sheet that follows along with this. So if you haven't found that, you might want to go back into Schoology and find that. This is the second page of what I posted. So if it doesn't look familiar, just look through because you might be looking at the other page and I'm just reversing the order. So we're going to talk through this. You can also obviously write on your own paper. And the other thing you might want to grab is your note sheet, or your vocab sheet that I posted. I'm guessing a lot of the words on the front side of the page look familiar to you. We now know the definition of a circle, and you know things like radius and diameter. Some of the words might be new, and we're going to kind of use this as we go along, but sort of work the words in as we need them. That being said, I want to take a minute and clarify on the back side of the vocabulary sheet. There are two words that I put in your notes last week, and some of you that didn't follow along the note sheet didn't see these questions. So there's some questions in your My Math Lab, just for you to recognize the difference between tangent lines and tangent circles. So if you want to find that note sheet and take a look at it, tangent means basically intersecting once. So we have what's called a tangent line, and that means that the line intersects my circle just one time right there. Okay, compared to another line that might intersect your circle twice. Let's take a look at that line, and that's what we call a secant line. That's on the front of your note sheet. When we have two circles, we can have a common tangent, and it can be two different things. If the tangent line goes between the two circles and intersects both of them once, we call that a common internal tangent. And if it goes on the same side, does not pass through the center between the circles, we call that a common external tangent. Okay, on your note sheet, it's just together in one picture. And then let's jump to tangent circles, that next term there. Tangent circles, again, means intersect once. So it means that either your circles are internally tangent, means one's inside of the other and they intersect each other twice. There it is, right there. Or one circle is outside of the other one and they're just touching. So I like to call those kissing circles. They're actually called externally tangent circles. Okay, hopefully that helps clarify that. Let's get into arcs and talking about arcs. A lot of this is going to be very intuitive, but I need you to follow along. I'm going to say a lot of things that I'm not writing down. So feel free to take whatever notes you need to, or again, look at that vocabulary sheet. So we've got two ways that we can talk about measuring arcs. And the first one is what we call linear measure. And that's when I think of linear measurement, I like to think of taking a length of something. And the weird thing is that it is curved. So when I'm talking about an arc, I'm talking about a part of the circle, maybe like this part right here that goes from R to I, and it's almost like a segment. It has two endpoints, but it starts and stops at one point, different points, but it's a curve, not a straight line or a straight segment. So the linear measurement is how long that would be if I actually straightened it out. So you could think of wrapping a tape measure around there. Units for linear measure would be units of length. And it's part of the distance all the way around the circle, which you should know what that is. Yeah, that's right. It's part of the circumference. So a fraction or a percentage of the circumference would be a good way to think of it. And we can find that pretty easily once we know the measure associated with the arc, which we call arc measure. So let me just write one more thing here. Units of length, if you have to give yourself an example, inches, feet, centimeters, anything like that. And then the second thing that we can talk about is what we call arc measure. And this is where we're going to live more in this circle unit, is we're going to be using arc measures a lot. But we're going to do both of them in this lesson. The arc measure is the angle measure. Whoops, good thing I can spell. The angle measure associated with the arc, and this is units of units that we would use to measure an angle, which could be degrees or radians. We're going to use degrees. So if you need to give yourself an example, wow, I need to work on my writing. Sorry, guys. Let's try that one more time. Okay, so degree measure, and that has to do with our central angle. So if you take a look at that vocab sheet again, a central angle is any angle that has a vertex at the center of the circle. So that seems pretty obvious right now, because the picture that we're looking at here, if we use this as our example right here, only has one point in the circle. But this point wouldn't have to be the exact center. So right now we're going to assume that any point that's in the circle is, and close to the center, is the center point. But eventually we're going to have to be told that, because we could have a point over here or here or here or anywhere. Or we could also talk about an angle that goes from R to I to P, and that would be, or from P to G to I, and those would be different kind of angles because the vertex point would be on the circle, not the center of the circle. So consider that an introduction to what's coming, and let's focus on those central angles for today. So central angle would be something like RSI or RSP. So what we know about arc measure is that the measure of this arc, which is not an angle, this is just part of the circle, this arc has a measure that's associated with the central angle. They're one and the same. So the measure of a minor arc is the measure of its central angle, is how we define that. Okay, and we'll talk about that in just a second. But right now, let's document what we just said. We just said that if, get rid of that. If this angle, central angle, is 55 degrees, then the arc from R to P is 55 degrees. Okay, so quick detour into English language for a second. We have some words that I want to talk about, and that would be minority, and majority. And we all know that a majority is more than half. Minority is less than half. So if we take off the ending of those words and we take just the major, not the T part, and the minor part, we have what's called a major and a minor arc. And the major arc is exactly what the majority is. It's more than half. The minor arc is less than half. So if we're going from R to P here, that's less than halfway around the circle, so we call that the minor arc. So then that means, what do we call something that goes halfway around the circle? It's not a minor arc, it's not a major arc. So what is it? Yep, you've got it. You've already heard that one before. That is called a semicircle. Maybe you wanted to put the word arc with that, and you felt like you needed to put something arc. That's called a semicircle. So as far as naming these, we name a minor arc with 2 letters. So we assume, this will make sense if you think about it, that if I just give you 2 letters, R to P, I'm telling you, I want you to go from R to P and go the shortest way around the circle. Because technically, you could go this way, or you could go all the way around that way. We're not going to take the long way unless we have to. So 2 letters, we assume that it is the shortest distance around the circle. So let's look at one more example here. I see 2 letters with this one. The little M in front is just like when I do this. Remember when I say the measure of angle? Oh, I've got it right there. The measure of an angle, because I want to ask you for that. We read that as measure of the angle. So this right here, we're going to read as measure of the arc from P to N. So if I'm going from P to N, well, here's P, here's N. I could go that way around the circle, or I could go this way around the circle. This one is a shorter way, so that's what I'm going to take. So how much is that? Well, I know this is 55 degrees. I can use, there's like an arc addition posture, just like an angle addition posture. I can add up arcs. So if I knew the measure of arc GN, then I could do the measure of arc PG plus the measure of arc GN. But it doesn't look like I know that, so let's look for a second. Well, I do know that P to I, since that segment PI passes through the center of the circle, that's a diameter. So I know that's halfway around the circle, that's a semicircle. And what's the measure of a semicircle? Yep, you got it. All the way around the circle is 360, because that's 360 degrees around a point, so 180 degrees is halfway around. Or you could think of it as the angle. Straight angle is 180 degrees, therefore the arc is 180 degrees. So I've got 180 degrees, but I don't want to go all the way that. I want to go this much, which is 20 degrees less than 180 degrees. There you go. We could just subtract 180 minus 20, and I'm getting 160 degrees for that. Okay. Now let's take a look above that. I know I'm not necessarily going in order. You can go whatever order you want. PRN, so I'm looking at measure of arc PRN here, And that is P to N. The beginning and ending letters are the same, but this time I have to pass through R. So I'm doing all of this. So if I already know P to N, the minor arc and the major arc completes a circle, then what could I do? Yeah, you got it. I could do 360 minus 160, and that's going to have to be 200 degrees. Or again, you could do addition here. This is 180 degrees, and let me point that out. This is 180 degrees, and then you've got 20 more than that. So 180 plus 20 gives you your 200 degrees. Okay, hopefully this is making some sense. I'm going to pause right here and just talk about naming arcs. So we said 3 letters. The beginning and the ending letter tells you where to start and stop. But what about that middle letter? So here we used R. Can you think of an arc name that would be, can you think of another way to name arc PRN? So you're referring to the same arc. In other words, I have to start at P, end at N, and tell you a point in the middle. Yeah, you got it. So you could say PIN, and that would be another name for that same arc. PIN. You can also reverse the letters. NIP and RP would be referring to this same arc right there that we just talked about. Okay, we can go in reverse. So looking down here, I'm looking at angle GSP. GSP, notice, is not drawn in. That's okay. I can go ahead and sketch that in for us. And GSP, it looks like this. That's a central angle since S is the center of the circle. And that's going to be the same measure as the arc. And the arc right there is 55 degrees. So therefore the angle is going to be 55 degrees. Okay, so I've got 2 more arcs, arc PGI. So PGI, starting here, passing through G and going to I. PGI is halfway around the circle, so that we already said is 180 degrees. And measure of angle RIP. So RIP is almost all the way around the circle. Notice when I said that, that might actually give you a way to find that, RIP, because it's almost all the way around. How much would all the way around the circle be? 360 degrees, and we're 55 degrees less than that. So you could individually find these arcs and add them all up, or you could do 360 minus 55, and I'm getting for that 305 degrees. Okay, so that's a pretty good intro to finding arc measures and naming arcs as well. I want us to make a quick observation, RP and PG. So I want us to focus on these 2 arcs from R to P and P to G on this picture. Notice that they're both 55 degrees. Okay, they also both share a point, and they just go in opposite directions. So we're going to put 2 names with these arcs. Vocabulary words that I believe are on your sheet. I'm checking right now. They may not be. Don't know if they're on your vocab sheet. So let's make sure we get these down because I don't see them there. They are congruent arcs and adjacent. That second word is arc. Adjacent arcs and congruent arcs. So, I kind of already talked through those, but let's just put a little note underneath those. So I'd like to point out that adjacent means they share exactly 1 point. So let's go up here for a second because we could talk about arcs that aren't adjacent. For instance, RP and RG are not adjacent. They still share 1 point, but they share a lot of other points. So PR and PG share only 1 point, not more than 1 point. So that's what adjacent means. And congruent arcs, they are obviously arcs with equal measure. And they can be on the same circle, but they don't have to be. So if they're not on the same circle, I'm having trouble writing small enough. Let's see if I can make this a little bit bigger. There we go. Okay, they're either on the same circle or they're on congruent circles. So we can have two different circles that have congruent arcs. We could also have two circles that have the same arc measure, but different. They're not congruent because they have different size. They have different lengths of radii, and therefore they're different sizes. So we'll look at that, some examples at another point. I will bring that concept back, but just a quick introduction. Okay, so a fun problem to try. Let's put some algebra with this. So let's practice finding arc measures. So you don't actually know any measures of arcs in this problem. I want you to stare at this for a minute and see what you can do. I'm sure you're excited to do some algebra. The question is, what is going to be the correct equation here? So rather than just jumping to solving something, let's make sure we like our equation. Okay. Hopefully you had a chance to do some brainstorming. You can obviously pause the video before you see the answers. So one option here we can always do is we could take all of these expressions, 4x plus, 3x minus 2 plus 3x plus 10 in no particular order plus 2x minus 12 and set it equal to 360. I think I got them all there. Because all the arcs add up to, all the angles and all the arcs add up to 360 degrees. Okay, but is there an easier way? So things that I look for, do I have angles that are equal to each other or arcs that are equal? So you have vertical angles you can look for. The same would apply to arcs if they're across from each other. You also have, is anybody else seeing something different? Yeah, I love that. Notice that we've got these two angles make a straight line. Good old linear pair from chapter 1 helping us out here. And therefore, this is a semicircle, so you might be thinking that. Some people visually see that better than the linear pair. Same thing, they add up to 180. So 4x plus 3x minus 2 equals 180. Your choice. You also obviously have the other side, and you could have set these 3 equal to 180 as well. Either way, you should get the same answer. So go ahead and solve, and then you can check your answer. So the correct answer should be x equals 26. And then go ahead and hopefully you found the arcs. This is good practice for finding arc measures. And those should be your arcs. Okay, now that you have a pretty good idea of how to figure out arc measure, we're going to remind ourselves that there's two ways to measure arcs that we talked about at the beginning of this lesson. So we've been focusing on this arc measure. Now let's switch over to this linear measure, and let's see how that plays out. And I'm going to take back to where you started this lesson. Before you got to this video, you should have done a Desmos activity that had to do with sectors of circles. So we're going to simultaneously kind of talk about that, which was talking about areas of sectors, a portion of a circle, and then talk about the arc measure, which would be the part of the sector, the part of the circumference of the circle, dealing with just that sector. So let's go ahead, and if you didn't do that activity, you should pause this video and go do it. If you did, then let's go ahead and work through this. So I'm going to get you started. Just a quick reminder, because you might not have these formulas memorized, that we have two formulas. We have a formula for area of a circle, and that is pi times radius squared. And the circumference of a circle is 2 times pi times radius, or pi times diameter. Either one is fine. I like to use radius just because then I'm always using radius, so personal choice. Okay, so I want you to find I'm going to pause the video. You can do this on your own. I want you to find the area of the circle or the part of the circle that is shown, and then you can pick up back with the video. Okay, so what I've done is I've found the area of the whole circle. Maybe you started with something like this, and 64 pi, obviously that's my answer there, but then I've got 9 pi would be this whole circle. So then I'm asking myself, how much of the circle do I have? What portion of the circle do I have? And I'm guessing that you did one of two things. You either divided by 4 or you multiplied by 1/4. And I'm going to do the exact same thing here. I'm going to divide by 4, and I'm just going to leave it as 9 pi over 4. But let's take a minute and ask ourselves, where does that 4 come from? Well, maybe you just visually said this. Let's divide it into fourths, and I have 1/4, thinking of how much of the pie do I have, or cake, or whatever that happens to be. But we could generalize this because I'm not always going to be able to just know off the top of my head. So hopefully the Desmos activity kind of helped you to think about, if you know the angle of the circle, you know the portion of the circle that you have. And that angle, so here's where the rest of our lesson comes in. Our arc measure, since our central angle is 90 degrees, I know I scribbled over it, our arc measure is 90 degrees. And I have 90 degrees out of 360 total. So there's my 1/4. We should just take a quick minute and talk about units because we're doing area. We're going to have square units. And we haven't done that a lot this year, but I know you've seen that before. So that would be my answer there. And that was my answer for the first one. So following along with that same reasoning, 240 degrees is the wrong part of the circle. I want this part, so that's 120 degrees. If my arcs add up to 360 degrees, central angle is 120, so I'm multiplying by 120 over 360, and hopefully you thought of that as 1/3, so I can literally just reduce that to 1/3. And then if I do the math there, 36 divided by 3 is 12 pi centimeters in this case squared. And then the last one, I'm multiplying by 9 degrees out of 360, and that's not always going to come out even, and that's why I showed you that we can just have a fraction like we have in this one. We can just leave it as a fraction. I could have divided that, but it was going to be a decimal, so I just like to leave it a fraction as long as it's in exact form. Fractions are preferred because they can be in exact form. So 9 divided by 360, I believe that does come out even to 1/40th, so we could divide by 40, which is going to give me 10 pi. And I'm back to inches for this one, square inches for my units. Okay, not squaring the pi or the 10, that's different. It's just my units squared, and I'm noticing that I forgot units up here, so let's fix that. Okay, so let's take a quick minute and let's talk about our generalization of what we're doing here, because I think you've got the idea, and then we can apply the same reasoning to arc length. So I'm going to go back to what we did with the Desmos activity, and I think by the end of that, you were coming up with, when they were having you find the angle measure, you were taking the sector area, you were dividing by the circle area to figure out how much of the circle did you have, and then multiplying it by 360. And that was giving you this arc measure. I'm going to call it M for arc measure, just to give me another variable. So I'm asking a little bit different question here because I'm telling you the angle. I'm not asking you for the angle. So we actually know this, and what we're trying to solve for right now is the sector area. So we're kind of reversing the question from what you were doing in the Desmos, but using the exact same reasoning that this portion of the whole multiplied by 360 gives me the measure. If I just do a little algebra on this and rearrange it, so I'm going to go ahead and divide by 360 on both sides, and then I'm going to multiply by C. Then I come to this equation. My sector area is equal to M over 360 times C. And C was my circle area. That was just the letter that they had you use in your Desmos. So if C is your circle area, that's, oops, can't remember my area of my circle formula. That's pi times radius squared. Your M over 360 is the portion of the circle that you have, and that gives you your sector area. So this is, I don't think I can move it out, what I would call the formula, if you will, for finding sector area. And exactly what we did here when you did these, you did, so I guess I'm changing what I'm calling it, and I'm calling it S here for the area. That was the area of the whole circle. These are S. So I guess this one, I can get rid of my S and just keep my A. But the other ones I found sector area by doing area of the circle. That's what this whole first part was, finding area of the circle, and then multiplying by my degree measure over 360, the portion of the circle that I have. Okay, hopefully that makes sense. I thought the Desmos was a very intuitive way of getting to that sort of relationship. It is a proportional relationship here. You could actually set it up as a proportion is another way of doing it. If you like that method, feel free to kind of take some liberties with this. Okay, I'm going to pause the video. I want you to work through the same thing. This time we're going to try to find a way of doing the same kind of reasoning, but with arc length as part of the circumference instead of area of the sector as part of the whole area. Okay, so I'm back with kind of the prep work done of figuring out arc length. And again, we're doing answering a separate question here of just using the same circles as my starting point. And so the full circumference for the first one was 16 pi feet. Notice my units are not squared this time. And now I found the circumference of all the other circles. But if you followed what I did last time, whoops, I forgot to go ahead and put in for that first one that my radius was 3. Radius here was 6, radius here was 20. And now what I need to do is I need to figure out what portion of the circle I had. So I can kind of go ahead and cheat. I'm going to be multiplying by 90 over 360. And when I say cheat, I mean, I already know that that's 1/4. So that's going to be over 4 or times 1/4. We said we could reduce that. And that's going to give me an answer of 3 pi over 2 feet for my arc length. So I'm probably going to call this L for arc length. But you can use whatever letter you want. I've seen it referred to as other things. This one is going to be times 1/3. So we had a 1/3 here, which is going to give me a final answer of 4 pi centimeters. And then this one, my last one is, we said 1/40th, which gives me actually just 1 pi. 1 pi inch, which is kind of a weird measurement. So I want you to take 1 minute before you finish this video. I know that we've done a lot of stuff. Thanks for hanging with me. And I just want to generalize what is it that we just did so that we have I don't even know if I want to think of it as a formula, because that indicates to me something I have to memorize, but a way of thinking. A formula is really just a way of generalizing our process so that we can make our work a little more efficient. So for arc length, what is it that I'm actually doing? And yeah, I'm thinking about what I did for sector area, and I took the area of my entire circle times the degrees over 360, the arc measure over 360. So let's just replace this with my circumference, which almost we could read from here that C was indicating circle area, but my circumference. So let's do, and it doesn't matter in what order you multiply, measure over 360 times circumference, which is 2 pi r. An extension would be, you could certainly look at what would this formula look like if you were using radian measure instead of angle measure in degrees, because we've got that 360 is the degree measure for the whole circle. So what is the whole measure? What is the radian measure for the entire circle? And you could look at the conversions there. But these would be the two formulas that you will be responsible for knowing or using to get answers. Thanks for sticking with me. Like I said, hopefully that's a pretty good introduction to circles.